Welcome back, everybody. This video is about 8.4, choosing a sample size for a study. I am going to divide this into two parts. 8.4 has kind of two major topics in it: choosing a sample size for a study, whether it's about proportions or means, but then also there is a section about comparing hypothesis tests and confidence intervals and how we can use the results of one to help us figure out the results of the other. So I am going to split this up into two parts just so that this video doesn't get too terribly long. But I wanted to start with a motivating example. This is just number 22 in our notes, but I want to start with this example so we can kind of talk through what this first part of 8.4 is about. So let's go ahead and read through this example. Suppose that you wanted to estimate the true proportion of students at your school who have a tattoo with 98% confidence and a margin of error of no more than 0.1. How many students should you survey? So obviously we're talking about a confidence interval here. So let's think about our formula. So we are trying to estimate a proportion of students who have a tattoo. So this would be building a confidence interval for a population proportion. So I'm going ahead and writing down the formula. Now the question here is, how many students should you have to survey in order to build a 98% confidence interval with a margin of error of no more than 0.1? So here we don't actually know what n is. We're solving for n. Also, we want our confidence interval to have a particular margin of error, no more than 0.1, or as a percent, no more than 10%. So we're given a stipulation on our margin of error, and that's how we're going to solve for n in this case. Remember, this part of our formula after the plus minus is the margin of error. So we're told that we want that part to be no more than or less than or equal to 0.10. So essentially we're going to set up an inequality. We're going to take the part of our formula that is the margin of error, and we know that we want that margin of error to be less than or equal to 0.1, and that was specified in our problem. So here's our inequality, and this is what we are actually trying to figure out. We're trying to figure out n such that this left side is in fact less than or equal to this 0.1. So that's the idea of solving for sample size. You're given these certain stipulations in our problem, and you are trying to algebraically solve an inequality in order to get a sample size, or n, that will achieve this confidence level and this margin of error. So that's the idea here. So let's go back to the beginning. Notice, if we're looking at this inequality, you would have to do a lot of algebra to get this in by itself. If you want to know some of those steps, or if you want to try that algebra on your own, you are certainly welcome to. I'm not going to take us through the algebra to solve for n there. I did actually create this other page here. If you want to go through and look at the steps to solve for n, you are more than welcome to. But we have the formula on this first page for us, and that's essentially all we've done, is just solve for n and that inequality that I just showed you. There's a couple different ways you can show it. So I've got, this is the one that the book has, and then if you just want to condense it a little bit, both of these things are squared, so we could put both of those in parentheses with a square. And then remember, 1 minus p hat is the same thing as q hat. So this here and this here mean the exact same thing, just a couple of different ways to write it. So let's talk about what we need to plug in to this formula. So here, Z star, remember, that comes from our confidence level, and we can look that up on StatCrunch. Our margin of error is what's specified to us in the problem, and then P hat and Q hat. Well, let's think about that for a second. P hat is our sample proportion. However, we haven't taken our sample yet because we don't even know our sample size. Remember, we're trying to determine what sample size is needed. So if we haven't taken a sample yet, then we certainly haven't calculated a sample proportion, or a p hat, yet. So that p hat and q hat, we want to use a p hat given to us from a previous study or we're going to use 0.5. So if you were given a p-hat from a previous study, then you want to use that information in the problem. But if you weren't, like in this tattoo example, we weren't given any indication of any p-hat from a previous study asking these students if they have a tattoo or not. So we're just going to use 0.5. So in 22, I've used this version of the formula, and we are just going to plug in everything that we know. So the 2.3263 came from StatCrunch. For a review of that, I would suggest going back to the 8.1 and 8.2 recap video so you can remember how to calculate that critical value using StatCrunch. So that came from StatCrunch. We've got our margin of error specified in the problem. We're squaring it, that's part of the formula, times p-hat times q-hat. So it's really important to note that this is an inequality that says greater than or equal to. Remember, we're looking for a number of students to survey. If you calculate this in your calculator, you're going to get a decimal, not necessarily a whole number. That's usually the case with all of these types of problems. And you want to think, well, we're asking a number of students. I can't ask 135.292 students. And because this inequality says greater than or equal to, we want to make sure we go to the next highest whole number. So that's why our answer would be at least 136 students. 23 is just another example. So running through this one quickly, a news poll estimated 82% of all voters believe global warming exists, with a margin of error of 3% or 0.03 as a proportion. An environmental group planning a follow-up survey on this issue wants to determine a 95% confidence interval with a margin of error of no more than 2%. How many people should be surveyed? So we have all this information from a previous study, but we are interested in doing a new study with 95% confidence with a new margin of error, not this old one, but a new one of no more than 2% or 0.02. So 95% confidence gives us a z-star of 1.96. Our margin of error, 0.02. In our previous study, we do have information from this previous study that our p-hat we can use is 0.82. So our 0.82 times our q-hat. Again, putting all that in your calculator, you're going to get a number that is not a whole number. But remember, we are going to round up to the next whole number because this says greater than or equal to, and we're talking about a number of people to survey. We cannot survey a fraction of a person. So our answer here would be at least 1,418 people should be surveyed. So flipping on to finding a sample size when you are dealing with a confidence interval for a population mean. So again, we have this nice formula here for us, but I want to take you to the next page. So we're not going to run through all of this algebra, but I want to kind of go through this the same way we did with the proportion. So here we've got our confidence interval formula for a population mean. Remember, we have our sample estimate or our point estimate plus or minus our t-star critical value, since we're dealing with means, times our standard error, which is sample standard deviation, over the square root of our sample size. So here's the issue. We can still set up our inequality like we did before, right? Here's the issue. We're solving for n. Remember, when we pull up the t calculator on StatCrunch or any t calculator, a t distribution depends on degrees of freedom. Degrees of freedom depends on sample size. So we don't know our sample size because remember, that's what we're trying to solve for. So if we don't know our sample size, we don't know degrees of freedom, which means we don't know which t distribution to use. Because of that issue, we have to use a z instead. That's our only choice. Z is going to be our best guess at that critical value. So we are using a z only because we are solving for sample size. And because we don't know sample size, we don't know degrees of freedom, which means we don't know our t value. Here, another thing to mention, s, lowercase s is sample standard deviation. we haven't even collected our sample yet because we haven't even figured out our sample size. Therefore, we don't know our sample standard deviation. So instead, you're going to use standard deviation from some previous study. Similar to the proportions, we might use a proportion from a previous study. You're going to use a standard deviation from a previous study to fill in there. So taking a look at our formula here, again, if you were to follow all this algebra, we would get this nice, beautiful inequality here. So again, just a couple of different ways to write it. All three of these things are squared. Remember, this means standard deviation. All three of these things are squared, so you could write them all together and then square that entire quantity. So let's take a look at an example, 25. Administrators at your school want to estimate how much time students spend on homework on average during a typical week. So we're trying to estimate a population mean. We want to estimate this with 90% confidence and a margin of error of at most 30 minutes. Our pilot study indicated that the standard deviation of time spent on homework per week is about 154 minutes. So remember, we need that standard deviation in order to fill that in our formula. Our question, how many students need to be surveyed to estimate the mean number of minutes spent on homework per week with 90% confidence and a margin of error of at most 30 minutes? So again, using our formula up here, I'm going to use this condensed version. Our standard deviation times our critical value. So our standard deviation, we're using that 154 from our pilot study. Our critical value, remember, we can't find a t because we don't even know the degrees of freedom since we don't know our sample size n. So we're going to use a z-star instead. So we can use StatCrunch for that again. 1.645 z-star critical value will give us a 90% confidence level. And then 30 is the margin of error we are trying to obtain, or at most 30 minutes. So that entire quantity squared gives us n is greater than or equal to 71.307. Again, that inequality says greater than or equal to, so we want to make sure that we round up to that next whole number. I'm going to let you guys read through this one. This one is very straightforward as well. So kind of check through and make sure you can figure out where each of those numbers came from. Again, remembering to round up to the next whole number. As always, I have some extra practice problems at the end. So this first one here is solving for sample size. I did put all of the extra practice problems for 8.4 all together, and because I'm splitting this up into two separate videos, if you wanted to go try number 30 and then come back to watch the rest of 8.4 or 8.4 part 2, and then you could try this one.